Hello everyone, this is Maushmi. Today I am here with yet another interesting problem on gravitation. But before I begin, I'd like to thank you all for the support we got. Now, proceeding further, we have lots of videos on different topics related to physics, chemistry, maths, English as well. So you can always stay tuned with Abdemi. The online registration procedure is going on. So kindly register. You can see a lot of videos on the various topics. Theory videos, we have uploaded a number of numerical videos. So hope you will enjoy all such videos. So kindly register and visit our website. So let's begin with the first problem. Two balls of mass m each are hung side by two long threads of equal length. The balls are displaced towards each other through equal distances. If the distance between upper ends is r, show that the distance r dash between the centers of the balls is given by g r dash squared times r minus r dash is equal to 2l gm. So let's begin by visualizing the problem in the form of a diagram. We have a rigid support. So we have a rigid support here. We choose 2 points and two balls are hung from these 2 points with long threads. Now, if you see, the two balls have the same mass. They are hung by two long threads of the same length. Suppose the length is given as L. The balls are displaced towards each other through equal distances. Initially, the distance between the upper two ends is given by little r, and they are now displaced through certain angles, say. This is the displacement of the first one. This is the displacement of the second ball, say. Displaced through angles theta. And suppose after that the separation between the two centers is given by little r dash. Now we need to find an expression for r dash in terms of this particular equation. Now let us analyze the forces which are acting on the balls. Now if you take a quick look at a single ball, let us consider one ball. Whatever is happening for a single one will also be the same for the second. Now assuming for this particular ball, what are the forces experienced by this ball? Now one force is the weight of the ball acting in the downward direction. So let's look at this. We have its weight acting in the downward direction. Weight is given by mg. This is one of the forces. The other force is nothing but the tension set up in the string. So this is the tension T set up in the string. And another is the gravitational force of attraction between the two bodies. The two bodies are displaced towards each other. So there is some gravitational force between the two bodies. So let us assume that force to be F. So these are the forces which are acting on the body, on each of the balls in fact. Forces acting on each ball are its weight, force of tension set up in the thread, and the gravitational force. Of attraction. Gravitational force is always attractive in nature. So the gravitational force of attraction. Now looking at the diagram, let us try and write down an expression for tan theta. So tan theta, Consider any one of the triangles. Now tan theta is nothing but perpendicular by the base. So if this is theta, this stands as the perpendicular and the base is nothing but this. So you can see from here that what is this distance? Now we need this distance as the perpendicular. If you see the net distance between the upper ends is given as little r, while after they are being displaced, the distance between them becomes r dash. So this distance is clearly nothing but, or if we assume the total distance, it is nothing but r minus r dash. Now, since they are displaced through equal distances, so each of these distance can be assumed to be equal to r minus r dash by 2. So, we have tan theta equals base perpendicular by base. Perpendicular is r minus r dash by 2 by the base, which is nothing but L. Now, we may consider the value of tan theta in terms of the forces. So here the perpendicular part, in this region the force that is active is nothing but the gravitational force written as F by the force acting along the base, that is this direction. This is nothing but the weight mg. Now in this relation what we can see is that we need to write down an expression for F. F is nothing but the gravitational force of attraction between the two balls. So let us apply Newton's universal law of gravitation to write an expression for this force. As we know, the gravitational force as per Newton's law of gravitation is nothing but g m1 m2 by r square, where r is the separation between the two bodies. So if we apply that, we have g m1 m2, the two balls have the same mass, so we have g mm by r square. The distance between the balls is given as r dash, and so we may write this as r dash square. So we get the value of F as g m square by r dash square. Let's substitute this value of F in this relation. We get r minus r dash by 2L is equal to, this is g m square by r dash square, and together with that in the denominator we have mg. So we are left with r minus r dash by 2L is equal to g m by r dash square times g, little g in fact. Now proceeding further with this, we can see that we are left with, let's keep an eye on the solution that we need. We need g r dash square r minus r dash. We have already got that. Let's just cross multiply. We have g r dash square times r minus r dash, which is equal to 2L capital G M. So very interesting result in fact. So we have many such videos in our website. So please stay tuned with Abdemi. Thank you.